Okay, so welcome everybody to the afternoon session of the final exams. We are at the...
Let me introduce first, and then maybe you schedule the student.
Sure.
Okay.
Mm-hmm.
Thanks. We are live. So we are in the second part of the first day at the Synthetic Landscape Lab. So today we will see the Bachelor of Design 2, which is being taught by myself with Corbinian Erzinger, and Maria Kupskova has been in charge of the portfolio design for the groups. We have as jury Teresa Greskova, Stefan Siegel, Daniel Stiletto, and Marco Poletto that will join us shortly. And we will see, I think, around 5 groups, no 4 today and 1 tomorrow. Okay, perfect. Corby, do you want to introduce the student?
Yeah, sure. Thanks for the introduction. So this year's design course was titled Mutualism, and the main goal was to explore our surrounding and natural environment, as well as the human-built environment, so we can better understand how one is affecting each other. So we started with a detailed analysis of certain organisms and their environment, and therefore we tried to expand our understanding how the relationship between human and non-human networks can be developed. So depending on the characteristics of the organisms, the goal was to develop new approaches of mutualism in that sense. So where both humans and non-human organisms can collaborate to improve each other's living conditions. Today we will see, like Claudia was mentioning, 4 groups, which all created a quite unique approach to the topic. And in this sense, we will start with the first group, with Hannah, Barbara, and Johanna, who will presenting their projects, which is dealing with water purification using an organism called Riccia fluitans. So you can start sharing your screen.
The host have to give the permission to the Bildschirmübertragung. Oh, no, it works. Thanks.
So, hi everyone. The name of our project is BioAquifer. An aquifer is a layer of earth containing groundwater or mineral water. And we took this as an inspiration, and we wanted to, in the end, come also up with a water containing layer which is adaptable and can be attached to all kinds of surfaces in the city, like facades, roofs, or grounds. Implied in our layer is an underwater plant called Riccia fluitans, which is also native in Austria. We mainly took this plant because of its main property, which is that the plant purifies the water and does overall cleansing. And therefore it is also, for example, used in aquariums. We then started off by analyzing the plant through a microscope and came up with these microscopic images, which we used as an input for our design later on. Maybe you can go to the next slide. Yes. And the idea is to collect the rainwater, and then the water fills the morphology, and we wanted to provide the surrounding with the cleaned and purified water. Therefore, we searched for a location in Innsbruck where much water is needed, and this happened to be the Haus der Musik, because there is a water feature near and also a water fountain. And next to the Haus der Musik, there is the Hofgarten, and there is a lot of water needed for watering the plants. And the Haus der Musik itself needs also a lot of fresh and clean water. And additionally, the water has a cooling effect on the rising city temperature.
We focus on the one microscopic picture and analyze it in detail. We started with the contour analysis, followed by the flowline analysis. This helped us to figure out where the water is running and where to place our plant, which is represented by the metaballs. In the following diagram, you can see more precisely how we started to figure out in which direction our geometry could head. On the right-hand side, you can see the analysis based on the microscopic pictures, with the water circulation and the elevated lines. And on the left-hand side, you can see our design approach with the plant itself, the protected skin, and our first geometrical outcome.
Now we had an idea how we wanted to develop our geometry, and so we looked for a place where we wanted to adapt the morphology, a public place where purified water is needed. So we came up with the idea to put it in the Haus of Music in Innsbruck. In further steps, we made a solar radiation analysis to know on which side of the facade of the House of Music we placed our geometry. The analysis was done on 4 days a year, each at the change of season. We came up to take the west side of the facade because there are about 7 hours of sunshine all year round, as you can see in the red areas. In a further step, the environment was brought in. Important here was a large tree which stands directly in front of our facade section. This made it interesting because the maximum hours of sun radiation, depending on the season, reached from only 8 hours in January to 16 hours in September.
As already mentioned, more particular, we focused on the marked part of the west facade because there the temperature values are suitable for the plant Riccia fluitans and because it tolerates a temperature from 4 to 35 degrees Celsius. And like said, we took in consideration that a tree is also providing shadow on the facade, and we made this 12-month solar radiation in form of thermal images, and you can see the average radiation per month. We then took this as an input for our next analysis and translated the colors into these points. The sizes of the points show the average number of hours for every part of the grid, which divides the facade we want to integrate the new morphology on. The next diagram shows the points which are most suitable with the most suitable solar radiation in all 12 months. And then we extracted the average of the highest solar radiation points and adjusted it to the facade and the windows of the Haus der Musik.
Based on the results of the solar analysis seen before, we started to develop a geometry which is perfectly adapted to our site. We used the outcoming points to generate a pipe system which takes over the carrying system of our main morphology. The main morphology is composed of the Riccia fluitans and the enveloping structure in which is the plant located and connected with each other. Yes. Here you can see the geometry with the Haus of the Musik, which is facade, its windows, and its surroundings.
In the next slices, you can see the final result of our project visualized in a rendering. First, we visualized the geometry alone. Then we adapted the geometry to the facade of the Haus of the Musik to see how it looks on the house. And with these pictures, we all want to thank you for your attention and your efforts, and a special thanks to Claudia, Carpini, and Maria. Thank you for your attention.
Thank you.
Thank you.
Thanks for your presentation. Let's open up for some comments.
So what was the theme of the studio again?
It was mutualism, basically how we can integrate an organism in the urban environment and take advantage of it.
So
mutualism, like forming a mutualistic relationship with an organism.
So how is in this project, how would you describe the particular form of mutualistic relationship that you have established?
I would say the relationship was to clean water and purified.
Relationship, mutualism. There is a mutualistic relationship between entities or systems. Who is part of this relationship? Who are the subjects, let's say, of this mutualistic relationship?
It's actually just a plant, and we use the property of the plant so that the surrounding gets provided, and also that the people have something from the plant itself.
So the relationship is between the plant and
the surrounding.
Who is the surrounding?
More
specifically, like who are surrounding is very generic.
Yeah, the surrounding is like the place or the location where the House of Music is located is a big place where a lot of people come and as a visit.
So the relationship is between the people and the plants.
Yes, yes.
Okay.
And also with the nature.
Right. So in that case, why are the plants encapsulated in bubbles, and why have you been avoiding very accurately to grow them in front of the window, where people may be able to touch them or see them or engage with them?
They're in bubbles because they're in water, because they needed to grow. And we cut out the window because before we had it above the window and the shadow, it was too much shadow inside then.
Okay. Clear.
Yeah, if I can say a short word, the presentation was good with this this method of translation of the sun studies, I guess, working into these data sets you used for the facade progress. But what I was not sure about is you have, for example, in this picture, you have this golden facade elements, and now, as Marco, for example, mentioned, is these encapsulated algae plants that are filtering the water. And in my opinion, how you started your project, it would be more or better to search maybe a solution which is much more integrated in this structure, because now it looks like a little bit artificial to me, having these both elements a little bit separated through these bubbles. Maybe you can think about the scale, or maybe how it would be more connected also with the whole structure. That would be my question. How could that work, maybe? Or is it simply just this data spots, these dots where you we worked with?
Yeah, basically it's adaptive to every facade overall, so it could also like lead around the corner and over the whole building. And we just focus on the one facade to give like an idea how it could work.
Mm-hmm. And why is it not covered the whole system, I would say, of this golden facade? Because is it now this date?
We started, we started with the Hofburg, and it's much more huger, and we had to focus on a small area because they started to get so big, and we crashed our system like every 5 minutes, and we had to stay small because also not our computers couldn't do it.
And we also had a better,
but of course it can't be
to focus on a small part, so we could like easily change little things and adapt to how we want it.
Mm-hmm. Yeah, just the mentioning that it looks a little bit artificial to me, too artificial, that maybe for the future just think about maybe some more integration into the actual facade. Yeah, thank you.
Okay, thanks.
Thank you.
If I can, I will just jump in myself also a little bit because it's still very unclear for me why we are looking at this picture. And I think both comments that you received previously were very relevant, and I think an answer that your computer is crashing is not really a good reason for you to change the scale. If you have a problem with data or with processing, you can visualize your idea in a different way. For example, I quite like the rendering that you showed before, where we see these bubbles and the system and the pipes on the black background. But the moment this building appears, it's almost irritating, I have to say. Yeah, this one, for example, it shows like you're trying to understand some kind of a system. You have connection between each bubbles. You probably think very well which bubble is connecting and how this branching system is actually working. And then instead of instead of seeing this building with this system just attached to it, I probably, if you had a different conceptual idea where you say you were thinking of a much larger scale, you could just change the technique. You could come back to the technique of drawing and draw the proposal in a different way than rendering it or modeling it in a 3D, so that your computer can handle it, but you can transfer your idea or communicate your idea further. Yeah, I think it's very important in your project, whether in this one or in any future project, as I understand your bachelor students, to really specifically think how you want to build your visual narrative in order to communicate a certain idea. So if there is a certain idea of mutualism, of connection of the plant to the human being, of connection to the plant, maybe even to the building, maybe even to the site and to the environment of the site, I need to be able to create a set of drawings that communicate that. So I don't show the building on a black background disconnected from the area, but I show the location, I show the orientation of the north, south, and west and east. I show the, I don't know, sun analysis of that, or I show the movement and the flow of the people around and or inside of the building, and what are the views and how I can actually get in touch with these objects. Otherwise, they are presented very disconnected rather than connected.
Yeah, I think that's a really relevant comment. Thanks, Teresa. Because, yeah, already, like we discussed a couple of times, like it's often better to first show it like as a really simple drawing, but that is really showing the idea how everything is connected together, and then going kind of to the step. Yeah, exactly. And then basically this drawing is showing the same information as your rendering itself, but it's already a lot more convincing, and it's probably less heavy when it comes to computation power. So I think this entire project could have been developed around a drawing like this, more in detail.
And this drawing could be expanded way more rather than just representing what we already see in the rendering itself. I think there is sometimes a lot of, sorry, I just continue a little bit. I think there is a lot of confusion sometimes, especially at the beginning of our studies, because and I still myself try to always be aware of not saying a final presentation, a final project, a final drawing, because these things make and wire our brain in a way as if this was the end, and is a little bit problematic in any stage. I mean, maybe this semester is the end for you, but what I'm trying to say is might not be the end for the idea to be pushed through, no? So rather than creating 5 drawings that represent the same, we can create several drawings that that give idea of possibilities and opportunities.
Thank you. Thank you. So are there any other comment on this project? Otherwise, I think we can move on to the next one.
Thank you.
Thank you.
Thank you. Thank you.
So we can continue with the next project with Julia and Anna.
Okay, so hello and welcome to our presentation. Anna and I are creating a facade system inspired by the cells of our moss. As first step, we collected moss in Innsbruck near the Bergisel and also in Aschau in the Silla Valley. Here you can see an overview of our moss types we collected. And to keep it short, I only say a few words about two of them. So the Ticranella heteromala doesn't grow high and it forms mats. It also has no problem with temperature fluctuations, but prefers places in the shadow. The main reason we choose this moss is its high tolerance to air pollution, which is quite important for our final achievement. The Polytrichum formosum can absorb around 15 times of its dry weight as water, and it's very common and can grow in quite sunny places. As side note, this is also our inspiration for our project name, Formosum. With our research, we took a look at how the moss would change when they dried out, and mosses don't only change in their form, but also their color. Some of these colors are used later on. In the time lapse, you can see how the moss reacts when it's being rehydrated and then it dries again.
Afterwards, we analyzed the mosses under the microscope. You can see how the cells vary between the different mosses. For example, the cells of the moss in the middle are more round than the other ones. And if we go further, we also compared how the cells change when they dried out or moist. So the dried out ones are much slimmer and drawn together, so those cells. And the cells of the Neum hornum moss are the main inspiration for our design. So therefore we analyzed this moss further. We analyzed the microscope images with different scripts and techniques. And here you can see two examples.
After our research, we looked for a way to create cells for our facade and used the information we collected. As a first step, we got the contour lines from a surface based on one of our microscope images. We cut it with a plane to get single cells, and these cells were the basis, and we used some metabol script to get our final cells. We created 5 cells for areas with a different amount of pollution. From cell A on the left-hand side to cell E on the right-hand side, the overgrown area gets smaller. The more pollution in the area, the more moss should grow there. Therefore, cell A is for areas with the highest pollution and cell E for areas with the least pollution. As you can see here, with our cell A, the cells don't only change their main shape, but they also change depending on the threshold of the metaboles. The more solid the cells are, the more solid cells are used on the areas with more sun. So the moss is a bit protected from the sun, and consequently, the porous cells are used where there's less sun. The same goes for cell B, cell C, cell D, and cell E. So they have all the same principle, but they just change their shape. And depending on the area our cells are located, we choose a moss from our research, which is best fit to its properties. So for areas with the highest pollution, the best fit is the Ticranella heteromala, and therefore it grows in cell A. The Hypnum compressiforme is also quite tolerant to air pollution and grows in cell B. And in cell C, you can find the Brachytetium brutabulum because it can handle sun, but it still prefers less sun and more shadow. Cell D hosts the Minium hornum, which is quite tolerant to the sun. And finally, in cell E, the Polytrichum formosum can be found because it can it can handle sun and save a lot of water. So it's a perfect fit for the areas with the most sunlight on our facade.
We want to install our facade system at the wall facing the Bozenplatz. It will be the white wall, which you can see in the background. If you go further, at this diagram, I want to explain the benefits of our systems. So mosses are able to bind and metabolize fine dust. Therefore, the location is very good because it is next to busy roads, and the people in the park can benefit from the filtered air. You can see this illustrated with the grayscale, which shows if we add our mosses, you get fresh and purified air. Therefore, there's less pollution on the left. And we also get the soundproofing effect with the mosses. We also did a sun analysis of our building. You can see the color scheme and the crosses of the grid change depending on the solar radiation. We input those parameters in our design, so each individual cell is changing depending on the solar radiation. This is based on the number values we got out of the sun analysis, where we have more sun and therefore higher values. The cells are solid or more solid, so that the moss is protected from the sun, and the less sun, the more porous they get. And we visualize those with the different colors. The brighter the color, the more sun they get. And here you can see the aggregation of the cells is based on a grid applied to the facade. And on the right-hand side, there is a street directly next to the facade. So there is the most pollution, and we use cell A here because this is the one which is less deformed, and therefore the cell has the highest overgrown area and can filter more fine dust. To the left side, where we have the least pollution, we are changing further till cell E, which is the most deformed one. And because of the deformation, the overgrown area gets smaller at the spots where we have less pollution. And the cells are orientated to the main water distribution point. Therefore, they create kind of a rotation toward this point. And at last, to get an inspiration how our facade looks at the location, we will show you two renderings. We also want to show that not just the people in the park benefit from the facade, but also insects and other animals could benefit from the moss. And in the next picture, you can see also the main road in the back, which affects our cell system and the part of the Bozenplatz next to the building. Thanks for your attention, and we're looking forward to your comments.
Thanks a lot.
Thank you. Maybe it's good to hear some feedback from others. For my side, well, I know the project very well. I think there has been a good step at the end. I see some evolution of the proposal of these panels. You know my comments very well, and from the last grid regarding the panels and regarding the mathematical distribution of them. But I think that you did a good step on the evolving this part. So maybe I just congratulate you so far. Thank you.
Thanks. Thank you.
Yeah, if I could say words, congratulations to your presentation. It was really professional, I would say. And it is a really good idea, especially at the Bozener Platz, to bring there some greenish in the city. because that's a critical area, I guess, in Innsbruck through all the years. But what I was thinking about is why you're stopping with this facade elements on the first floor and not maybe imagining going down to the street, crossing the street with some moss ideas, or maybe there is a moss bridge or something leading into the whole area, and also integrating through the whole place. So why you are just focusing on this part of the facade? Is there not more potential to grow or make the city even greener?
Yeah, sure. That's a good idea. It's a very good idea. We didn't think about it to get it down on the floor, but there's quite a lot of shops on the first floor, so that's why we kind of concentrated on the top floors.
Okay. But it's just a paneling system, which is not leading maybe into the whole structure or on the roof or something like that. It's just this kind of like facade on this side.
Yes, exactly. It's just
okay. Mm-hmm. Okay, thank you.
Thanks.
If I may have just a short word on that. Thanks for your presentation. I liked it very much. And I think it's a nice idea to have a look on the facades in the city, because. But my question is, how did you decide for that facade? I didn't get that point. What was the decision?
Because, yeah, for the mosses, we said we want to install it in Innsbruck because the mosses are found there, so it's their environment and it's easier to grow them in here. And then we looked where we have the goals that also the people can benefit from our system. So it was the idea to do it maybe next to a park or a place where we have lots of people. And the other thing was that the mosses should filter the air. So we found the Bolzenplatz good because there's lots of traffic. And so we need to get the air filtered, and the benefit is that the park is next to it.
Okay.
Yeah, and also another point is that the facade is kind of a north facade, and it's better for the moss than a south or west facing facade.
Yeah. Okay. But and what was the reason for exactly this facade? Because there are a lot of north facades there in this area, I think. Now that the question is, maybe you had some research on the context of your site, and there was a competition held just last year for the redesign of the Bolzenplatz. Did you have time to spend some thoughts on that as well? Because I would agree to Daniel. It's that the integrative thinking. I'm also missing some integrative thinking into the place, into the ground, and to the shops. So I don't see a problem if the shops are also affected by your system. But I like the fact that you want to purify the air through these plants. I like this idea very much, of course.
Also, one fact that you brought to the conversation that I actually also didn't think about in the beginning is that the Bolzenplatz is kind of surrounded by these streets, and it's kind of a noisy place where nobody actually likes to spend time in that sense. And that the moss, besides having the capabilities of filtering the air pollutants, also could have has the effect of soundproofing, so kind of absorbing the noise pollutants, which I thought was like a really nice aspect to bring into this conversation, especially on the Bolzenplatz.
Yeah, it's also a good benefit for the people living in the flats, in the house.
So this is a project that is really about doing good, like just making the space of the city better, bringing more nature to the city, right?
Yeah.
Yes.
Okay. So why did you spend all your time playing with grasshopper? I mean, I wonder, why didn't you just make moss tiles and install them on a wall? I mean, this is something you can do in a week easily, right? Like just take some, containers, put some moss inside, install it in a wall, cover it. That would do good, like for real, right? So why would you spend 3 months creating weird bubble shape with metaballs if your ambition is to do good to society?
Yeah, we analyzed the mosses at home, so we had them also there and kind of tried to keep them alive. Yeah, but we don't look at to actually build the models in real life.
Just go back 1 sec on the few slides. So that was a bit of a nasty question, but actually it's a fair enough question, right? Because you see all these these shapes that you have here, right?
Yeah.
Yeah.
All of these shapes here. Why did you do them? I mean, I don't see the need to do them at all. Why did you do them in the first place? I mean, what's their role or their agency or the motivation for making all these drawings?
Yeah, we had all the research and the microscope image, and we want to use the microscope image, parts of it, to create new cells which can host our mosses.
But why? Why do you want to do that? Like, what drives you in doing that?
Because it should be inspired by the mosses we had. So
Well, I mean, one thing is to actually stick some moss on a wall. Another thing is to making digital shapes based on microscopic images of the moss. It's just two completely different things, right? Like they don't relate to each other at all. It doesn't mean that if it's a shape is derived by a script looking at the microscopic image of a moss, it's a better shape to grow moss on a facade. I don't think so. There's no reason for that to be the case. So there must be something else. There must be something else. And if you have spent 3 months doing it, you must have asked yourself why and what is that something else. I mean, because at the moment I have to say that on one side I appreciate the graphic, the aesthetic of the project. On the other side, it was also surreal to hear you speaking about it, because your narrative was the most reductionist I could think of. Moss as a nature was reduced to an algorithm of an image to make shapes, if you want. And on the other side, so nature became a kind of form-making tool. And on the other side, these algorithmic processes became kind of tiles, like objects or typologies, right? So in a way, I feel that there is a complete misalignment between the richness and beauty of some of the drawings you have made and the way you talk about them. And this, for me, it's really a problem, because as a designer, you cannot allow yourself to disconnect completely from what you draw. Like, the drawing is your main tool to not only transfer ideas, convey ideas, but also to think. It's your main tool to imagine a new world, a better world, a healthier world, if that's your ambition, right? So, I think that's for me where something went wrong in the conceptualization of what you were doing at some point. I feel that there is a disconnection between the way you describe the project and the kind of complexity and articulation that your drawings seem to be describing. And so I think this needs to be addressed, because otherwise it's only going to bring you in a situation where you won't be able to answer questions that are legitimate and that, you know, will become actually quite problematic for you.
Mm-hmm. Yeah.
And, you know, specifically because you clearly show some sensibility for drawing. I mean, if you go back one more page, maybe just go one more page back, one more. Yeah, like, yeah, these pages are quite beautiful, and they represent an attempt to engage with these natural patterns and formations and through a digital technique. And I mean, you haven't said a word about it. I mean, you haven't said a word about what these digital drawings mean or represent. What do you think do they capture about the beauty of nature, the mutualistic relationship that these plants establish with their substratum, with the surrounding environment, with the ecosystems they are part of? I mean, I don't know. You know, this is about mutualism, and it's about, and then, you know, you spend a considerable time working with these beautiful organisms and analyzing and photographing them and filming them and 3D scanning them, you know, modeling them, drawing them. And there is nothing of all that that interests you, that fascinates you, that you think it's worth, you know, moving into the design phase to give that final project something of that beauty, of that poetry. I don't know. I mean, that's what I found really quite surprising. And you know, often I don't know, because you guys obviously are lucky enough to live in an area that is rich of this life and unique forms of life. And I think at a basic level, like, being a designer is being fascinated from, you know, the world that surrounds us, whether it's a natural one or whether it's a you know, architectural one, artistic one, you know. But you know, if we just you know, move through things with like robots, we you know, with kind of procedures that we follow without ever engaging with them, then, you know, what's the point of being a designer? You know, that's my reaction. And I think that there is a disconnection here that I don't know where it's coming from, but it needs to be addressed. And you know, because otherwise it's yeah, it's a pity. You know, there is just a lot of beautiful elements that are really lost in the process.
Thank you, Marco. That's absolutely important to have this discussion, like summing up the project and thinking for the guys how they could push this type of work forward. And that definitely we also need to evolve the way how we talk about the project and how we think about them as well.
I mean, what is the point of doing this Moss's analysis, for example? Like, I really don't get it. Like, what is that you extrapolated from this phase of the project that fascinates you, that made you really excited and wanted to do more with it? It's not clear for me, and it should be obvious.
Well, can I just jump in here? Like, I agree that the cells themselves are extracted by just because of their aesthetics, let's say. But the way the morphology of these individual cells are changing is quite closely related to what mosses they're supposed to host and the environmental factors, let's say. So the closer we get to the street where the pollution is higher, the more the cells can host the moss, and they're also quite closely related to the environment, because moss basically has the main problem.
That's a reductionist thinking, Corbinian. This is extremely reductionist, because mosses are complex organisms. They don't work like that. They don't work like a slider. So, for me, the moment you do this kind of exercise and you extrapolate parameters, qualities from these mosses, it cannot be just a kind of direct indexing or some kind of anthropic phenomenon that we happen to be talking about. It has to be richer than that. And in this particular case, of course, you can see how these different mosses have clearly distinct qualities in their material organization and their resolution, the density, the patterns of distribution of the leaves or these hairs. All of these qualities can be captured, can be indexed, and can be translated into a kind of algorithmic logic if we want to. But the point here is not necessarily how do we reduce mosses to an algorithm. I think on the contrary is how do we use this process to enlighten ourselves about some of the mutualistic properties or qualities that these organisms possess or have evolved, and how perhaps we can take that lesson into the design realm through these type of techniques, right? And so that's where I think the missing link is, in my opinion, that I don't feel that translation or that inspiration has been necessarily brought into the project. Then again, it doesn't mean that the project it shows that they have worked. Of course, it shows that they have a sensibility for drawing, and that's why I'm also insisting on this, because I think that this sensibility is there, but needs to be cultivated, needs to be nurtured. And if it's overwritten by a reductionist narrative, then it will just disappear and fail. And that's the harsh truth about design. It's a long process of cultivation, of culturalization, and when there is a spark of something, it needs to be recognized and nurtured. And I not kind of run over by some kind of reductionist protocol that is applied to everything and everyone. That's just my point.
Should we move on? Yeah.
Okay, thank you for the feedback.
Thank you, guys.
Thank you.
So let's continue with the next presentation.
Well, good afternoon. We are Pia, Julia, and Anna, and we'll be presenting our project called Green Crevices. For the architectural structure, we've been learning from the natural growth habits of mosses. Our aim was to develop surfaces that imitate rock crevices to provide shade areas where fine material settles and good water distribution all over the geometry. With the fulfillment of these basic requirements, we want to propose the mosses as a surface where the growth, which is often unpopular in urban areas. For the cell structure, we have been exploring different surfaces that we got from the height field of the microscope images for their potential of hosting mosses because of the density of mountains and valleys. The first one is the Sphagnum Moss, which has this interesting cell structure and can be found in Everglades. We choose this one because of the darker patch and the overall beautiful organic pattern. The next one is the Calpita streptocarpa. This moss can be found in soil and shady habitats. And what we think about this structure is that it's very interesting, these repetitive shapes that remains to brick cells, which as the sphagnum has a lot of darker patches as well, that separates the different cells. Then the last one is the Mnium hornum, which grows in soil and sun-exposed habitats. This cell structure, we think it's very interesting because of the very organic shapes that it has. Our next step has been to study these cell structures and try to represent them in drawings. So we could work with them, and these are the results that we got. This is from the sphagnum, this one from the Calpita streptocarpa. This one we also have, and then the last one from the Mnium hornum.
Our next step was to make a flowline analysis of these 3D structures to see how rainwater would react to them. We did this in all the previously shown structures in a 45-degree angle as shown in the first row, and in a 90-degree angle shown on the second row. We then proceeded to work on synthetic crevices to create an optimized structure with the perfect environment for moss to grow in. In doing so, we first made a surface displacement with the flow lines and the morphed structures, and then we morphed them with the original cell structures. In the first column, you can see the displaced flow lines, and the rest are the morphed structures. From left to right, the target surface height, the middle height, and the precision from base to surface varies to get different results. From this catalog, we choose the most dense and interesting structures and ended up with 3 different structures from Eucalypta estiocarpa and Mnium hornum and the Sphagnum moss.
In the next step, we analyzed the new geometry. We analyzed the new geometry and came to the conclusion that we still need to improve 3 parameters of the morphology. At the first stage, the radiation is still quite high. There are just a few regions which are flat enough to slow down the water flow, and the water follows at some parts mainly the ridges of the surface and doesn't really flow into the crevices. The method we chose to improve those parameters was a second displacement with short and dense flow lines. The outcome is a refined morphology with a lot of slots, what decreases the radiation, increases flat regions, which improves the adhesion of the mosses, and also leads to a better water distribution into the crevices themselves. I missed the slide. So in these images, you can see that there is a huge difference in the annual solar radiation between the 2 stages. of the surface. So the newly created slots are creating a lot of shape. The static part of our project would be that growth is limited by the environmental conditions which are caused by the morphology. So the surface wouldn't just look overgrown, but rather would the natural cover be a planned outcome. Based on the solar radiation analysis, we assume that we can predict the areas of healthy and dense moss growth on the surface because most mosses prefer to grow in areas with more shade. The darker the spots are here in these drawings, the lower is the radiation and the higher would be the predicted density of moss growth. And this is the comparison of the flat regions that influence, beside the adhesion of the mosses, also the settlement of fine material, which is kind of a fertilizer for the moss growth. And of course, also the water flow. Here you can see the differences in the flow lines with the same amount of starting points. While in the first stage, the water follows the ridges, the slots of the displaced surface lead the water into the crevices and improve the water distribution over the surface. Somebody of you? No?
Yes, in this slide, what we did was studying in the different parts of the viaduct Vogel from Innsbruck, the noise, the air pollution, the estimation of air pollution based on the traffic noise. And what we did was measure the decibels. So then we could apply it to the structure to see how it would change.
Based on the average noise level and the orientations of the measurement points on our site, we made a catalog that should explain how the morphology changes at each position of the site. The depth of the displacement, which are ranging between 2.15 and 0.5 centimeters, should ensure that the moss has more space with good growing conditions where the air pollution is higher and have a positive effect on the fine dust concentration of the surrounding. This also leads to a fluent change of the static caused by the growth along the site.
Here we did a Flowline's variation catalog, which is based on the different orientations and the different angles that the surface would be in. And we had did this slide and next one.
And this is a comparison of 4 positions on the site. We have 4 orientations, and the lowest and the highest vary of displacement, and 2 in between. You can see that there is a difference in the depth, and this is causing also a difference in the areas of growth. Thanks for your attention.
Thank you, guys. So, any comments from the external guests? Or?
In a way, it's kind of good that they sort of refused to you know, kind of reduce the project to some kind of a facade paneling, although that sounds like what they had in mind. But in the drawings, it remains more open, and therefore we are allowed to just enjoy these really beautiful drawings, really, really nice, beautiful drawings. But in a way, the project stops halfway, you know. So if you go before, there is a moment where you have a little bit of a bigger section of this, and you know, at that point, maybe you want to go back.
Which page do you mean?
I don't know, just go back. I think there is one page in which we see a bigger pattern, like not just a close-up, but we see a bigger pattern, no?
This one.
Yeah, perhaps, exactly. This scale here, no? So that's somehow the where the project ends, in a sense, because of course later on you have articulated more. I really like this idea of the second order of articulation to, you know, to retain the water. Makes a lot of sense. The analogy with the crevices and the cracks, I think it makes a lot of sense as well. And it's simple, but you know, the way you took it through this kind of design exploration, it's really beautiful. And again, I appreciate the fact that, you know, you kind of resisted to sort of, you know, stick a window in the middle or do some stuff like that. But at the same time, of course, the problem is that on the other end, you didn't propose any alternative. So, you know, we have this kind of endless tapestry. And now what is that it can do, if not covering a huge blind surface, maybe like a factory or a shopping mall, I don't know. But yeah, I think that's basically the kind of missing opportunity here. Although I have to say that there are enough elements for this project to feel more sophisticated, and so it's very good. But at the same time, I don't know, if I was you, I would spend the next couple of weeks just doing some crazy extrapolation of what this could be, because otherwise, again, you kind of in a way playing too safe, no? And that's a pity, especially since that you guys are in a stage of your curriculum where you can take risks. I mean, nobody's gonna trash you, right? I mean, or maybe we will, but in a good way, in a sense that yeah, it is really the time where you have to try stuff, you know, because, you know, the more stuff you try, the more you get a sense for it, and, you know, and then you progress. So yeah, I mean, I think that's where I think this two order of articulation that you have nested one into the other is really beautiful. Now I would like to see how maybe there is a third order that can come out, maybe a more simple one. I don't know, maybe it's a more simple form, or it's a more you know, that's kind of gets articulated, gets corrugated through these, you know, I don't know, but I think it will be really nice to try, and because the scale, the resolution, it's fundamental here. Of course, the moss defines one scale, one resolution, you know, the size of the crack or the little articulation, that's absolutely dictated by the moss. And you haven't clarified that how much, but I think that's something that it's clearly should be done or can be done. But what else, you know, what else defines the resolution or the scale of this pattern? Maybe it is the necessity for this pattern to allow for light or air to go through, and so I don't know, maybe all of a sudden the middle of these eyes, these kind of parts, maybe they need to be open actually, maybe, who knows, no? And then there is another order of articulation that comes in here. But then maybe overall, is there another scale? Is it the scale of a building? Is it the scale of a human, or is it the scale of a landscape? What defines a third order of articulation of this? And so that we can appreciate it. I mean, you were mapping a street, no?
Yes,
so do you mean articulating the entire street with this? Is it going to be like a pavement, or is it going to be vertical, or is it actually wrapping the two? Is it a new kind of urban landscape? I don't know. I mean, I think that's what would be nice to see, right? I mean, at the moment I cannot imagine, but it is also not very difficult to project it in some way, and to create a whole new layer. I don't know if that's what you intend to do or not, but
the plan was to implement it on the viaduct arches where the train goes
on
over.
the where, sorry?
The viaduct arches in Innsbruck where the train goes over.
I see. Do you have photos of it? I'm not too sure actually at the moment which arches you're referring to.
It's if you know it, near Still Park. Probably not. So it's 1.7 kilometers long, and it has two sides, and especially the back side is pretty messy.
Okay.
And unused, and our original plan was to treat those spaces in Innsbruck which are unused and unloved, and give them back to nature. And
right. And then what happened? What is that hijacked your plan?
What do you mean?
What happened? Why it didn't happen, this plan that you had?
Yeah, because of a lack of grasshopper knowledge. Because
come on, surely you can go there, like do 50 photos, create like a montage, and then Photoshop your facade on top of it or something. I mean, it takes like an afternoon. I mean, surely if you want to show your idea, you will find a way. I mean, honestly, guys, you have to completely get rid of these excuses and things, because if the tools you're learning are enabling you to talk about architecture in a different way, then it's fantastic. If they become an excuse to say, oh, sorry, I couldn't finish the project because I don't have a big enough computer, then you're not doing any favor to yourself, right? So you have to be able to say at some point, okay, screw grasshopper, I've done enough. Now I just go out there and I do a collage, or I do a photo, Photoshop, or I do something, because, at the moment you just lost an opportunity effectively to show your ideas to an international audience. And I would not allow myself to waste opportunities like that, especially when you have such good material. And, even just a quick montage, but a nicely done one. But it will help a lot. It will create a lot of room for discussion. You could do a video, like very simple video, where like one simple image just kind of pans through as if you were kind of walking along the street and along these long new moss walls and so on. You can do so many things to illustrate this idea, and in a very hands-on way. And I guess it's very important that you are able to use these techniques not only as a way of learning new computing skills, but to open up and to expand the way you read your city. So effectively it should become a new stimulus to go out there and to abstract, analyze, and then transform your city. And And clearly you have all the skills to do that, but at the same time, I feel that you just gave up on proposing a final vision for it, which I think it's a pity, but yeah.
Thanks for the comment.
If I may jump in for just a few words, I think with this, well, at first, innovations, design innovations, they must be appealing in order to be accepted. And with this step-by-step process of analysis and transformation, I think you found a distinctive aesthetic vocabulary for your purposes. And I like the extensive the environmental parameters that you have been incorporating. Seems to be extensive some way, especially the noise measurements. Did you make them these measurements yourself? How did you get this data?
With the phone, so they're probably not very accurate.
Okay, but that's the first step. Okay,
the idea.
Yeah, because I think you choose a good place for that as well. The viaduct, which carries the trains. I think it's a spot for a lot of problems concerning regarding noise. So I think it's positive that you didn't think in the first place to just to use it as a facade or think in a facade. It's positive that I think you can use think in a much larger scale with that material that you have. Because the conventional way, there are complaints in this area because of the noise from the trains and so on. Because it's the neighborhood between living and transport is quite high. So the conventional solution was to establish these noise barrier walls, which are not very innovative. So your project could show a very innovative way, at least in this point.
Thank you.
Thank you.
Okay.
Yeah, sorry.
Yes, please go for it.
Okay, thank you. Yeah, I think the project has much potential. As for example, Marco said, for me, the scale would be very interesting of this pattern. Like, so when you're working with this pattern, and you're showing here now the Bögen as a architectural spot, it would be very interesting for me. How would this spot look like? So we have these small cafes, restaurants in here. The small bureaus, how would they be affected by this noise pollution? And also, what would be the potential of the whole area? So we have there these huge buildings, but a lot of this area is concrete desert, I would say. And how would that be completely influencing? So is there a potential of creating new ecosystem or green lung through these train lines? And also, when you're looking here at this pattern, could this be much more as just a intervention on a wall? So maybe it could be a new building, or how you cover the train station or the train road. All these is just an idea for your future planning. So not just think on this smallest scale, I would say. Think big, especially in Innsbruck. I would say you can do that at the faculty, because in other states they are really strict. And here you have the potential, for example, maybe choose this pattern one day and try out how the city of Innsbruck would look like if that would be this pattern covered all in moss or something like that. So be a little bit more experimental, I would say, but as a starting point, good work. Thank you.
Thanks.
Thank you.
Thanks for all the comments.
Yeah, and I mean, in a sense, I agree totally. And being experimental doesn't mean like to do just random crazy things. But, you know, right now, for example, you have a very clear parameter that is the resolution of this pattern. You have a very clear way of controlling this resolution. Everything is kind of mapped out, you know, on a grid. Everything is computational. So you can very easily begin to play the game of scaling, you know, 10 times and then 10 times and then 10 times again, or scaling down what happens if you do that, you know, in a very speculative but also very rigorous way. You know, like what if this is a, you know, is a tile of 10 by 10 centimeter, or, you know, 1 meter by 1 meter, or 10 meter by 10 meter, or 100 meter by 100 meter laying down, or, you know, maybe these crevices, these cracks become actually as tall as buildings, and so on and so forth, you know, like, so all of a sudden you can begin to test these logics at, you know, different order of magnitudes, for example, and see what are the implications, you know, from the scale of the moss to the scale of a building, or of a portion of a city, of a neighborhood, of a human body, or, you know, and so on and so forth. That you know, can be done very rigorously, the same way as you have done all now, but at the same time much more speculatively in terms of what, you know, it triggers in terms of visions, because, you know, all of a sudden is confronted with very different orders, and you know, and in that sense becomes mutualistic to very different kind of systems, you know, from the infrastructural system all the way down to the little biological organism. You know?
Yeah, thank you, Marco, Daniel, and Stefan, for the comments. I think that's a really fitting comments. I totally agree, especially with the step. I think you have like a super nice project, but what Marco said, I think, is hitting the nail on the head, or I don't know if you said in English like this as well, but you kind of went the safe way. You just stopped until the point where you are sure that it's kind of working and so on, but you weren't brave enough, let's say, to go this last step and just to speculate how could this be applied? How could this make an impact in the city? So this is basically just the last step that was kind of missing for me. The rest of the project, I think, is quite clear and really good. So thank you for that.
Oh, can we 3D print one of these, by the way, or just for the sake of? And because I think it would be quite good, no, to have like one of these tiles or whatever they are to see like physically, and maybe inoculated with the plants as well, and, you know, see what happens. I mean, you have the model, everything, and I don't know, maybe you can go to the lab and 3D print one. I don't know. I think it would make a lot of sense, no?
If that's an option, I would love to. Yeah.
I mean, you can go out of your home now, right? Good. It's up. Yeah, it's getting more. It's getting better there too, right?
Sure.
Yeah. No, because if it's possible, I think it would be good. It's just another element that is really missing, in a sense. And I'm sure that you would have done it in a normal year, or you would have been forced to do it. But, you know, at this point, maybe you can do it, even if it's a little bit later, or during the summer, you know, when you have time, or when the lab is open or available. You know, I think it's worthwhile.
Would be interesting, yeah.
To see how you can render all these textures in real material, especially these two layer of pattern, no? The bigger undulation and the finer grain. It would be nice to see it.
Okay. think we can move on if there's no other comments. We have one group left. This is Samuel.
Yes, sir. First, I will share my screen. And here we go. Yeah, hello also from my side, and welcome to Project Patron. So Patron describes one who protects and supports a defender and advocate. And staying with this theme, I really focused my research on these two domains where they create mediators between city and nature. So they really go into the same direction, replacing technological polluters like, for example, energy non-efficient filtration systems, etc., and also plastics. And so this really sparked my interest, and I thought to myself, okay, when they are already working to the same direction, why is there, at least to my knowledge, no solution which tries to combine these two parts? And therefore, my idea was, I hope, Marco, you won't hate it, but to create a symbiotic facade panel. Because the reason really is, of course, we have these innovative approaches of new architectural designs, but we shouldn't forget that all the cities are already built, and now let's see what we can do with the existing buildings. So this symbiotic approach really works on two levels. I would call it the intrinsic part, where mycelium provides the whole the optimal surroundings for the plants to grow and thrive. So really providing water, proper sun exposure, and also a semi-open structure so that wind can provide nutrients. And then on a second level, this is where you can say the circle is closed, because this very panel can then also be an insulation for noise, heat, water, and shock resistance, of course, and even flame retardant. And the city dwellers will then also be included into this approach by providing the nutrients like CO2, humidity, and also the fine dust, which in normal cases is a great problem in cities. But there, the plants can extract minerals from this fine dust and use it as nutrients. And in the reverse, it will, the greenery will provide purified and cooled water and air. So the first part of my project really revolved around this physical prototyping, because I didn't only want to create a digital work, but also try to prove it. So really grow, in this case, moss, because it's very space and nutrient efficient. And in particular, I decided to use sphagnum and common liverwort because of their antiseptic and fungicidal properties, which, again, in combination with the mycelium, seems very useful when implemented onto a facade. And therefore, I really grew these exact two species to then plant them on the mycelium. And on the side of the mycelium, I decided to use pearl oyster mushroom because its mycelium is particularly dense and fast growing. And in general, the cool thing about mycelium growth is that you can put it literally in any form and it will grow around what it finds. And then also through experimentation with different substrates and techniques, you can even adjust the material properties of the mycelium. So to make it, for example, like paper, like rubber, or even like wood or plastics. And so the first version was really like a first step into this domain to see, okay, how does such a pre-made substrate work, and how to experiment with different densities. So I compressed the substrate at different densities, and then looked into how the rigidity, so the stability, then differs. And of course, one might say the denser it got, the more force it could bear. And in this case, it was like a really poppy breaking apart. And you can see from the color, like it is quite brown, that the mycelium didn't grow throughout the whole structure. So I adjusted in the second version the sun exposure and also the humidity levels and the air distribution, so that it can then be much denser growth. But on the other hand, with this new substrate with bigger pieces, the problem was rather that the wood chips weren't able to be compressed further. So didn't get the same density levels and stability levels. But in the third version, of course, I tried to take care of that and included also straw and refined the whole structure, the whole substrate. And then even planted it into a final mold, which creation you will see in the next step, in the digital part. But in general, it worked out pretty good for about 2 or 3 weeks, and then like the pH levels or the whole system collapsed, and unfortunately mold buildup and the mycelium itself stagnated. So this was to uneven density and humidity levels. And just to give you a picture of the final state before I discarded it, it looked like this. And nonetheless, of course, even if there's no finished prototype in this case, the digital form findings, so the digital work was quite a success, because I decided to look into working systems in nature, like deltas and deserts, which are already formed by water and wind. So I really knew that they will work with water and wind, of course, because they're formed by it. And the deserts were chosen for the inner part of the structure to plant the mosses on. So it was important to have a great surface size and also a slow water distribution, which I proved with this comparison of average stream lengths. So the longer the stream, the slower it will flow, and the more even the water distribution will then be throughout the facade. And on the other hand, for the outer part, the deltas seemed quite useful because they have rather clearly defined structures, so ideal for directed wind and sun distribution. And of course, I already also proved this by choosing the best combination of the I wanted to have a low maximum hours and a high minimum hours. So to really work in a space where the mosses will have like half a day of sun exposure, which is especially for these species like the optimal range. And then before assembling them, I just did a few modifications, like these lateral cutouts so that they can be put together. And also, like on the right lower side, you can see those that you can see through the whole structure, so the water can flow from panel to another panel. And this I also tried to show in these simulations, where I put several panels together and just animated the whole thing again. And you can see on the left-hand side, the water flows quite regularly throughout the whole facade. And also the shadowing works, of course, independent from the number of panels. So yeah, even if it was not successful on the physics part, nonetheless, I found it very interesting also to see this like dance between simplicity and also complexity, because when you think about just putting greens on a facade, of course there's much more to it, and also these digital tools, of course, when used according to the microorganisms and plants, can be very useful. So yeah, thank you very much, and this was my presentation.
Thanks, Samuel. Let's open up for comments, feedback.
So ultimately, what is the project here? Is the panel? Is a panel?
Mm-hmm. Like a prototype for a panel, like I would say a facade ecosystem.
Facade ecosystem.
Mm-hmm.
How is it an ecosystem again?
So these were these two levels I described. It works intrinsically, the mycelium plus the plants, and then the moss in this case, and then of course other plants can go in, and mycelium in general is...
So the mycelium is used to create the substratum, basically, like to help bind the material and create a substratum for the moss to grow.
Exactly, and then we have this enclosure for the plants. And with the plants, of course, come other animals and insects and so on. And
so why didn't you say that it failed? I didn't get that, because you said that it was not successful, but I wasn't sure why.
Yeah, the physical part, because I really wanted to create this exact panel that you see in front of you, with the actual moss and the mycelium panels. But the mycelium part failed because, yeah, it was, I think it needed more iterations so that I can really find what works best for this exact mold. Because as you saw in previous test panels, it worked fine. But when it got to a more complex form, of course, there were parts that were deeper in the mold and some were higher up, and then the humidity distribution was not even. And then mold built up and the mycelium didn't grow. So, yeah.
And where do we see that?
Of course.
Because I don't know. I mean, again, I think that what you are saying now in terms of the depth, creating different distribution of humidity, which led to contamination and therefore, let's say, a reduced ability for the mycelium to spread.
Mm-hmm.
Sounds like a pretty fascinating ecological process in itself, right?
Yeah, of course, it was.
Exactly. So how is that a failure? I mean, you have created what you just claimed before it was your aim, that is an ecological system, which may not be 100% under control or fine-tuned. But I don't even know whether that is ever going to be possible, by the way, because from my experience, whenever you try to create an artificial ecosystem outdoor, let's say in the open, by definition is subject to contamination. And so it may well be that this failure, it's actually the most poignant representation of what is going to actually be the reality of your system than the one that you are imagining in your digital models. So in a way, if I was you, before dismissing it as a failure, I would rather try to draw it and depict it as accurately as possible, because perhaps from that realization, there is an insight in the way the system may actually evolve to become truly what you want, that is an artificial ecology that can exist within the fabric of architecture. So again, I think that there is a kind of a form of a latent, let's say, reductionism in the narrative, which in a way your models and your experiments are already overcoming in a sense, but maybe you needed to recognize that. And here I would connect to the other point, which is the aesthetic of your presentation and the drawing, because far from being just a superficial makeup, for us, aesthetic, it's really a way of highlighting, of bringing to the foreground the minute patterns, the minute differences that in ecological system often lead to macro changes in the long run. So, for example, if you would take more care in the photographing and in the abstracting of your material samples, maybe we would not be so distracted by the pattern of your wooden floor, and we would be able to detect better this kind of gradient of humidity that you're talking about, and the way the mycelium has responded to them, or let's say this particular struggle that happened between the mycelium and the molds, which ultimately resulted in the component, being the way it is. So, in a sense, I feel that your idea of form finding should be evolved into an idea of pattern breeding, perhaps, where you try to extrapolate from your experiments these minuscule differences that are in reality so significant to you, and that can turn into patterns, can turn into new formal or material organizations, and eventually can also help you develop the design of your prototype or your system. So I think that there are very good elements, and then on the other hand there are very poor elements, and I think that if the poor elements would be improved, I think the good element could become exceptional elements because you would be able to recognize them rather than dismiss them as a failure. You would be able to perhaps recognize that in their uniqueness there is actually a key in perhaps developing a new reading for your project that is way more interesting than the reading that you already have in your mind.
Okay. Yeah, first of all, I totally agree with, especially with these points of the visual language. On the other hand, I admit, of course, I didn't mention this, so no wonder. But the plan here really is like these panels are baked in, they are baked at 150, or no, like 100 degrees Celsius in an oven. So at this point, at this stage, the mycelium, the mushroom is dead. So it won't interact with any other like microorganisms, etc. When applied to a facade, for example. So that's why I said this was a failure, because the plan was that it would have this whole white mycelium coverage and be a solid part, and then I could bake it, and then it will be like a final inert form. But yeah, I didn't mention this, so of course.
I understand that, but since architecture is not like baking to a certain extent, there are elements that are worthwhile highlighting. As a matter of fact, even when you do baking, there are elements that that very minute differences in your dough may lead to a completely different result. So my point here is not to question, let's say, the process, is rather to question the approach towards it. And you know, before you fully lock in the final result, it would be useful to expand on the process to the point in which the process itself engenders form or design ideas, right? So you allow the process to become part of the creative development of the project, rather than, you know, locking it into a final result that you have already determined before the beginning of it, right? So that's where my observation was trying to aim you, like.
Yeah. And by the way, you're absolutely right. So this was my exact approach. So in the beginning, set the direction and then follow. But yeah, okay.
Which is absolutely fine if it helps you moving forward faster, as long as you allow your direction to be reset whenever you discover something interesting along the way.
Okay.
Yeah, thanks for your comments, Marco. Do anybody else wants to give some feedback?
Yeah, maybe. Well, I think the approach of thinking in terms of renovation measures, we are talking about a facade element. I think for the existing buildings, it's very pragmatic, but it's also promising, I think. But of course, cities they do not exist of only facades. They're also and above all the space between the facades. But of course, you concentrated on that element, and I like your serious testing, and this is actually generating experience in the cultivation. And I also think that your form finding considerations, they are a good combination of this recent trial-based thinking, and as far as I understood, also they're coming from intuitive decisions as well. And so I think that the aesthetic evolution in this project is easy to follow here as well. But I think I like your spirit, how you approached towards that project.
Okay.
Thanks.
Yeah.
Yeah, thank you for your presentation. I have just a question. Did you get in contact, for example, with the Tyrolean Glückspilze in Innsbruck?
No, I didn't, because I looked into what they're offering, and what I tried to get from them were those little inoculated grains, but they first had to set them up and have to wait 3 weeks or so. So I ordered it from another source, and also this pre-med substrate. So just in terms of time management.
Okay. Yeah, because I know some guys from there were producing ideas for bricks, for huge tiles, for construction areas, and also thinking about how the mycelium or these mushroom plants could not only be integrated into an urban filtration system, but also in furniture and stuff like that. So I guess this idea of yours with bringing the mycelium or the mushrooms into the city is a really important step, because what you can also mention in your book or something like that is that you can keep a really good material acquisition through that. So you need just a little bit of water and short periods of time for growing these mushrooms and the substrates. So yeah, these are just small thinkings of that. Yeah, thank you.
Okay. Yeah, but cool. Nice. Thanks for the tip. Very cool.
Yeah, I think it's definitely worth experimenting a bit more, even though the course is over now. But I think it's a quite interesting topic that you can, yeah, like I would even like to do it in my free time, you know, like just experimenting a bit more if you're interested in it, how to create a module or how you can make it actually.
Yeah, and also my plan was like the perfect scenario would be creating this module and then comparing it to conventional insulation modules, for example. So how the heat insulation, etc. is. But yeah, before that, it has to be created, of course.
Thank you, thank you. So you can maybe stop sharing. We can have some final remarks. If anybody has final remarks, I would like to thank the guest and all the students. I would say this year possibly has been a little bit more challenging than last year, because last year with many of you we met in person. In this year has not been possible, and I hope next year we will be able to evolve the format more. I can see in all the project element of research that are relevant. I would welcome all the students to keep reflecting on how these can contribute to architecture, because maybe in some of the project the translation was a little bit direct, or that's what we could achieve this year. But surely there has been a development in terms of project technique and in terms of prototyping and biological observation. But what coexistent means, maybe it's not been completely untapped in the course, which is okay because we are a second year course. But I would say don't stop there. Don't think that that's what coexistent is, because there could be much more. And if we want to have an ecological approach through design, we need to invent a new word, not simply correct the one that exists, which we are often tempted to do. So, but I think there were some beautiful moments in all the project, but it's the overall that I think still needs work, but you have time, and somehow that's also the challenge, or what you can come next. Are there any other final remarks?
Yeah, I just want to say thanks to everybody, first off to the jury for joining, and also to the students for the semester, even though it was kind of a challenging time doing everything online. But I think you still put a lot of effort in it and try to make the best out of the projects. So you all have some really good steps in your projects. Of course, there's always parts that have to be or can be developed further. But yeah, would be looking forward to seeing some of you the following semesters to kind of go a bit more into depth in some of these parts.
Yeah, I also would join and thank you guys for your contribution this semester. I agree it was challenging, and I think we kind of, what I feel that we a bit lost the physicality, but not in the sense that we just haven't seen each other, but in the projects. I sometimes felt that kind of we are like within the development, you are stopping to associate the drawing with the real design piece. And that's why maybe there was a bit of a struggle that how we come from the drawing to the like imagining the architecture, and how do we push forward just some patterns. Now there's like, there were some great steps in all the projects, but how do we actually bring it to the actualization of the design piece? There may be some steps were missing. But it's a great effort, and I think that you all learn some language that we develop at the Synthetic Landscape Lab, and I hope you did enjoy and got some knowledge that we managed to share with you. Should we?
I think I talked a lot already, so maybe I don't gonna take much more time. But yeah, just thank you for your efforts, and we, of course, I had a fun day, and it was really nice to see also the variety of work and projects. I think that other than that, I'm looking forward to be in Innsbruck physically again. I think very soon in August probably, and you know, hopefully, as Claudia was saying, to be able to interact more with you personally and to get more hands-on again with some of the prototypes. I mean, having said that, I think, you know, if some of you wants to pursue that, you know, and I think it's good to do it in the next few weeks. Try to materialize some of the things that you have done. Could be a nice task for the summer, you know, and in preparation for the next year, I'm sure it will be very useful. But otherwise, yeah, have a good break.
Thank you. Thank you all. See you back tomorrow morning.
Thank you.
Bye-bye. See you tomorrow.